Hello, this is Mr. Wood, and this video is over Logic, Reasoning, and Proofs Part 1. So logic is a very fun topic in geometry that uses a lot of common sense. It does have a lot of vocabulary and reading involved, so make sure you learn all the words, names, and formulas. There will be very little math calculations here. The first word is conjecture. A conjecture is a statement that may be true or false. A conjecture can be proven false by providing at least one counterexample. The counterexample can be a number, drawing, or statement. So one counterexample is how we disprove things. So here's an example of a conjecture. When you add two numbers together, the answer will be 10. Now, you know, a plus 2 is 10, 5 plus 5 is 10, 1 plus 9 is 10, even 13 plus negative 3 is 10. So there's a lot of numbers that do add up 10, but not everything adds to 10. So one counterexample is 8 plus 7 is not 10, because 8 plus 7 is 15. Here's another conjecture. A number multiplied by 0 will be 0. Well, we can't disprove that, so that's true. Here's another one. If A, B, and C are 3 points, then they form a triangle. All that's mostly true. One time it could be false if A, B, and C are collinear on the same line. So you can't form a triangle there. Alright, the next word is conditional statements. If-then statements are called conditional statements. The general format is P arrow Q, which we read as if P, then Q, or we need to say P implies Q. P is the hypothesis and is the words after the word if, but does not include the word if itself. Q is the conclusion. It stands for the words after the word then without including the word then. And you will have to check the truth value, whether the statement is true or false, as well for each of these, the whole thing. So here's an example. If you are taking geometry, then you are in a math class. So our hypothesis, the P, is you are taking geometry. The conclusion, Q, is you are in a math class. So you only know the first thing. So if I tell you, if you're taking geometry, does that guarantee you're in a math class? The answer is yes. So this is true. Here's another example. If today is Saturday, then tomorrow is Tuesday. So hypothesis, today is Saturday. Conclusion, tomorrow is Tuesday. So all we know is this first part. Today is Saturday. Does that guarantee tomorrow is Tuesday? Hopefully you know that's false. Alright, so our counterexample is if today is Saturday, then tomorrow should be Sunday. Alright, we have related conditionals. These are the three other statements based on the conditional P to Q. Alright, they simply rearrange or negate the hypothesis and conclusion. You will need to memorize the formulas for each of these. Before I list them, let me talk about negating. Negating means to say the opposite of. The icon is a squiggly sign or a tilde symbol. For example, the squiggly P is read as not P, or is opposite of P. So if P, the original P, goes to the left, then not P means goes to the right. If P is equal to 9 degrees, then not P would be does not equal 9 degrees. You just use opposite meaning, the antonym, or you can just add the word not or isn't in front of it. So the first of the three is the converse. The converse is the conditional, but both parts reverse. So its form will be Q arrow P. So if Q, then P. Be very careful, as the truth value of the converse does not always match the truth value of the conditional. It sometimes does, sometimes does not. Here's an example. If today is Monday, then tomorrow is Tuesday. So we know today is Monday. Does that guarantee tomorrow is Tuesday? The answer is yes, true. Converse, or reverse it. If tomorrow is Tuesday, then today's Monday. So all we know is the first part. If I tell you tomorrow is Tuesday, can you guarantee that today is Monday? The answer is yes, that's also true. Here's the reverse of another one that fails. So if you get in a fight at school, then you'll get a write-up. That's true. Now reverse it. If you get a write-up, that means you got in a fight at school. So if you got a write-up, can you guarantee that that's because it was a fight? The answer is no. You could have got a write-up for skipping, getting caught skipping, too many tardies, being out of ID or dress code, or having electronic out. There's lots of reasons why you could have got a write-up. Alright, one extra note that's actually pretty important is the biconditional. If the conditional and its converse are both true, you can create a biconditional statement. The formula is P double arrow Q. And this is read as P if and only if Q, or sometimes you abbreviate as P if with two F's, Q. So, if a polygon has 8 sides, then it is an octagon. So if you know it has 8 sides, can you name it, say it's octagon? The answer is yes, true. Think of a stop sign. Let's reverse it. If a polygon is octagon, then it has 8 sides. That is also true. So I can now combine this into a biconditional. A polygon has 8 sides if and only if it is an octagon. That's true. So a biconditional is only true if it's true going forwards and backwards. The next related conditional is called the inverse. It's conditional but both parts negated. So you do not change the order. The form is squiggly P, arrow, squiggly Q. So if not P, then not Q. Again, be careful, as the truth value of the inverse does not always match the truth value of the conditional. It sometimes does, sometimes doesn't. Here's an example. Conditional. If the problem is 2 plus 4, then the answer is 6. Again, you only know the first part. So if I tell you, here, you have 2 plus 4, can you tell me anything about it? You say, yes, the answer should be 6. You combine them. Alright, now if I do the inverse, if I do the squiggly, the knots of each, the first part, P becomes not P. So if the problem is not 2 plus 4, can you guarantee that the answer is not 6? Again, all you know is it's not 2 plus 4. I have a random problem on this piece of paper. Can you guarantee the answer is not 6? I just eliminated one single possibility. It could be 5 plus 1, 2 times 3, 8 minus 2. Alright, so this is false. Counterexample again, the problem could be 5 plus 1. Just because I cross one possibility out doesn't mean the other possibilities won't give me the answer 6. The last of the three is the contrapositive. It's a conditional with both parts reversed and negated. It's the formula not Q, then not P. Alright, now this truth value will always match the truth value of the conditional. Alright, so here's an example. If it is snowing outside, or if it's snowing, then it's cold outside. That's true. So if it's snowing, can you tell me it's cold? Yes, you can guarantee that. What if I do the contrapositive? Typo right there. Alright. So if it is not cold outside, see how I reversed it, put Q first and the opposite? Then it is not snowing. So I put P second and I did the opposite, negated. So all you know is it's not cold outside. Can you guarantee me it's not snowing? Answer is yes. That is true. Alright, so the truth value of the contrapositive will always match the truth value of the conditional. So these will both be true or both be false. Alright, the conditional and the contrary will always have matching truth values, so we call them logically equivalent. The converse and inverse also have matching truth values, so we call those logically equivalent as well. So again, what that means is if one is true, the other is true, or if one is false, the other is false. Alright, one more example, all four. Here's conditional. They have to give you the conditional. So again, it's P to Q. If you live in Houston, then you live in Texas. So all I know is right now you're in Houston. Does that mean you're in Texas? The answer is yes, that's true. Let's try the converse. I'm just going to switch the order. So if you live in Texas, then you live in Houston. So all you know is you're in Texas. Does that guarantee you're in Houston? The answer is no, that's false. You could be in Austin. So if you're in Texas, you could be living in Austin. Alright, let's try the inverse. So not P, then not Q. So if you don't live in Houston, then you don't live in Texas. All you know is you're not in Houston right now. Does that guarantee you're not in Texas? Answer is no. You could be in Dallas, which is still in Texas. Again, you only know the first part of each sentence, the if part, the hypothesis. Let's try the contrapositive. Alright, if you don't live in Texas, then you don't live in Houston. So all you know is you're not in Texas at all. You have been in some other state or country. Does that guarantee you're not in Houston? The answer is yes, that's true. Alright, one last thing. Yep, is the truth table for conditionals. This is kind of confusing. If P is true and Q is true, then P to Q, the conditional itself, is true. So each little piece can have its own truth or false value. Alright, if P is true, Q is false, then P to Q is false. If P is false, Q is true, then P to Q is true. If P is false, Q is false, then P to Q is true. So notice if the hypothesis is false, these bottom two are the confusing ones. The overall conditional is considered true since we don't know what will happen. Here's an example. If Ryan notices it is raining outside, then he will bring an umbrella. So the first part, true, true, true. So if he notices it's raining and he brings an umbrella, that is a good thing. If he notices it's raining and he does not bring his umbrella, that's false, the opposite of that, then he's in trouble. Alright, now the reverse. If he does not notice it's raining and he brings an umbrella, is that okay? If he doesn't notice it's raining and he doesn't bring an umbrella, is that okay? We don't know. The only condition only tells us what's happening if he notices something. Right? He could or could not bring an umbrella if it's not raining by default. Alright, so it could be raining too. So by default, we call this true. So that's why if the hypothesis is false, we really don't know anything about the situation. It could be anything. We just say, alright, true. Doesn't matter what happened second. Alright, that's it for the video. Hope you enjoyed it. Make sure you ask any questions. See you soon. Thanks. Bye.